It's my great honor to present here today. And my presentation title is Lunar Lava Tube and its Skylight. I'm Junichi Haruyama. Actually, the moon is the nearest celestial body to the Earth. But it is needless to say that the moon is the first step for humans to go to the space. But you know that the environment of the surface of the moon is very, very harsh. Actually, a micrometeorite bombardment, the temperature oscillation is very wide from the minus 150 degrees to the 120 degrees. And the radiation status, radiation condition is terrible. Actually, if we put or construct the lunar base, then we make some launcher system. And the launcher system brought out and the ejector provided. So and the temperature is very, very high. And the radiation condition, the observed maximum value is 4.2 sievert. It is fatal, and you know the terrible places. Moon. But, however, the time is coming. Humans to return to the moon. In 2009, 10 years ago, Selene, our mission discovered a strange feature on the moon. This is the Maris Hills region here, and there are the volcanoes, past volcanoes. And this river-like feature is lava rivers. And here, this square, we found a very strange one. That is a very huge hole. The diameter is 50 meters. And this image was taken at a solar elevation angle of 45 degrees. So that we cannot see any floors of the hole. So this hole is very, very deep, at least diameter range of 50 meters. So that we hypothesized this hole is possibly a skylight of a cave, like lava tubes. Maybe you know the lava tube, but today I'll a little bit explain. What is lava tube? The volcano erupts, then lava flows, and the surface of the lava cools down. But if the lava is very, very low viscosity one, then lava flows in, and when the volcano eruption ceases, then lava tube or lava tube-like feature remain. This is lava tube, like this. You know that there are a lot of lava tubes in Hawaii, Big Island, and also in our country, Japan, there are some lava tubes on the foot of the Mount Fuji. If you have a chance to come to Japan, please visit the lava tube there. And the lava tube is a good shelter on the moon, you know. Actually, if we have a lava tube on the moon, the ceiling protects instruments and humans. And no problem, you know, the micrometer, no problem. And the temperature, perhaps very, very mild. From my calculation, about minus 20 degrees in the lava tube at the near equator places. And we don't afraid radiation condition. So the lava tube is very, very good places. And perhaps we discover the entrance of the subsurface safe area. So we automatically looked for the other lava tube or skylight. And from our result, we Selene discovered 3 huge holes of several tenths of meters in diameter and depth on the moon. Actually, later the LRO, the United States lunar spacecraft, found a little bit smaller or shallower pits. But perhaps these 3 are very, very largest one. The location, this is Maris Hills here, and Tranquitatis, you know, the Apollo 11 landing site near here. And on the far side, we found a very large one, Mare Engine region. So we hypothesize the lunar hole must be a skylight of lava tube. And this figure, this image, it was taken by the United States LRO camera. From this image, we understand actually this hole is the entrance of the subsurface caves, perhaps a lava tube. You can see there is a very clear boundary border here. From our Terran cameras on board Selene, taken a very black hole. But some people thought perhaps that hole was very, very deep one, but perhaps just like a test tube in laboratory. But from this figure, this image, it is not like a test tube in a science laboratory, science subject. Actually, there is a very, very clear boundary. And this place is a floor. And we can see any mound here. If the cratering, then meteorite cratering made such one crater. And around the crater, there are some limbs like this. But we cannot see any limb here. So that perhaps there is a vacancy and some small impacts or some fracturing. And then the sealing the collapse, then the lava tube skylight hole emerged. So that if we construct the lunar base under the ground, this place is very, very good because there is no big boulders, craters around here. From our Japanese engineers said, our Japanese engineering accuracy to land is 100 meters. So this hole's diameter is 100 meters, so there is not so many boulders and craters. So that if we can land on near here and approach there, there's no problem. But of course, there are funnel-like feature and very vertical road and some boulders on the floor. We should solve these problems, issues. But anyway, this place is very, very good for the truncated hole here. And another one, Marius Hills hole. Near the hole, also there is not so many craters or boulders. So that we can construct this area. We can construct the lunar base under the ground that we can expect. And but some people doubt. Okay, perhaps there is some vacancy under the ground, but it is not a lava tube like a very, very elongated one. But from the LRO observation, another evidence, these are possible lava tube. There is a sun illuminated deeper side, and if the camera is slightly oblique, then we can get some picture in the deep area. Actually, this one is nadir. Nadir is a straight line. Please remember these boulders, blocks, and from the nadir. And the oblique condition image like this. Here, this crescent area is outcrops here. And this is boulder, and we can see the space, which means here. So at least a smaller 20-meter or longer space area, vacancy area elongated or expanded under the ground. And this picture was taken from the western side to eastern side. But this one is another side, from the eastern side to the western side. And these walls. So that anyway, there is some vacancy, apparently open. So for the largest one, Mare Truncatus hole, the diameter is 100 meters, and overhang depth is 100 meters, 107 meters like this, and overhang is 47 meters. So the height is 60 meters, very, very high, and the deeper side is horizontal depth is more than 20 meters. So I have to provide some example. Perhaps this one. Home insurance building in Chicago. Perhaps in old days, this is one of the world's first skyscraper, highest one. But now, and even this one, we can construct inside lava tube here. And another example is Olympic Games Stadium, Tokyo, 2020. If you have a chance, please come to Japan for the Olympic Games. And this one's height is about 50 meters. So that we can construct the Olympic stadium inside the lava tube. So the lava tube like this, and perhaps we can see the Earth from the bottom of the lava tube. Anyway, So, however, even so, there are intact long lava tube under the ground of the moon that some people doubted. So the great result is from this university, Purdue, and Merosh team. They analyzed the gravity data from the grave, and they found mass deficit areas extending from this area. And this is lava little and mass deficit. So they concluded very long lava tube paths exist. And we found additionally evidence of the existence of intact lava tube in this area by using lunar radar sounder. Our satellite, Kaguya, Serene, installed 4 big long dipole antenna, tip to tips is 30 meter. And the frequency is 5 megahertz center, and provide 5 megahertz frequency radar, and then we checked the data. And we found, first, of course, there are a lot reflection from the surface, but some area, strangely, second peak we can detect. Perhaps this reflection of the radar is we hypothesize these are from the lava tube. So we check such a feature, and then we found these one example. And these areas consistent with grade mass deficit area anyway. And this is a hole here, and T1, T2, T4. We can get some strange secondary reflection. So that we hypothesize that there are some lava tubes here. And now that we expanding the research area and found some other places, for example, northern part and other places. But here I have to say that this area, the lava tube condition interpreted from the radar, consistent with mass deficit of grade data. But other places are a little bit inconsistent, some places. Anyway. Now that we are checking. And actually, this result is was done with support by the Merosh groups. And we, Japanese team and the Merosh group, tightly discussed, and especially younger ones discussed deeply, so that these good results are obtained. Thank you very much, Merosh. Anyway, so now we explained that lava tube is very, very good for the future lunar base or to utilize this one. But I want to say that lava tube or cave is a treasure of science, actually. So we can see the very, very good strata. Geologists like these strata or outcrops. And actually, the surface of this area is all lavas are covered. And the lava flowed about 3.5 gigayears old. So that these strata, the lava flows are older than the surface lavas. So the older than the 3.5 gigayears old. And we can get, if we can get some samples from here, we can understand what kind of the volcanic history and what kind of material come from the inside mantle field like this. And if and also if we enter the inside lava tube, this place is a very great places because on the surface of the moon, there are a lot of micrometeor bombardment. So the surface is crushed and destroyed. But inside lavas are fresh, no fractured, no space weathered. And if we get these materials, we can understand what is the fresh material from the inside. And also the inside lava places, there are a lot of the good places for the research for the earthquake, moonquake, like that. Also, I would like to expand a little bit one more. This is a magnet metal condition. And from the sample or the some meteorite, lunar meteorite, recently we understand the moon had, not now, had magnetic field in all time past. And recently, even this is all time and current, and even 1 giga years old, the moon has some magnetic field. That value is 1 microtesla. 1 microtesla is not so, it seems like not so large, but the moon is small. And we calculated the magnetic field around the core of the moon. Then the magnetic field of the core in past in about 1 giga years old, similar to the current Earth core mantle boundary, the magnetic field like this. Very, very large magnetic field occurred. And 4 giga years old, the magnetic field is 100 microtesla. So the 100 times bigger magnetic field occurred in past on the moon. So that we should know the why such one. Or is it really true such a magnetic field occurred? So that if small body, celestial moon-like bodies have such a magnetic field, then the magnetic field protect the solar wind or radiation, then maybe some life. Of course, not the moon, but in other planetary system, other planet or other star, other sun system, maybe even the body is very small, but maybe the magnetic field occurred. So the very, very important information will be gotten in a laboratory, we expect. And you know the surface, if the lava solidified, then the magnetic field is stored. But on the surface, difficult because there are a lot of the bombardment, so the surface crushed and the magnetic moment randomly becomes random. So the inside laboratory is very, very good. And actually, we are now the inside laboratory, we can get some lava field, the magnetic field stored in lava, on the lava. Anyway, next one, science Mars. Maybe you know that on the Haruyama Mountain, Olympus Mountain, biggest mountain, and big mountain here. Near the Haruyama Mountain, there are a lot of pits, perhaps skylight hole of lava tube. We already found by Cushing. And recently, we understood Martian observation team, MRO team, provided some pits near the even the Elysium Moon. Elysium Moon is you know this place is surrounded by flat or very lower elevation area, which means in all time in past this Elysium Moon surrounded by water, sea. Yes, so the ocean. So the even the Elysium near the Elysium, on the foot of the Elysium, like such pits are already found. So that you know that these laboratory is very good for the, of course, to construct the Martian base, and we understand the Martian volcanic history, but also you understand inside laboratory on the Mars, something there we expect. Or we don't know what kind of something there, but it's a good places because on the surface of the Mars is suffered from the ultraviolet bombardment now, so that we cannot see or we cannot find out any life. I think on the surface of the Mars, but inside or under the ground, perhaps Martian life can survive. Actually, the temperature condition is a little bit cold, but from the MRO data, these areas have a 20 Celsius degree in summertime, very short time, summertime. But in summertime, the temperature becomes higher. And if we I check the temperature pressure condition, then inside laboratory, or this area, some small amount of liquid water exists, maybe. So that we can expect something inside laboratory. Okay, but Mars is far, so we first aim to the moon. So that now, again, time is coming, human return to the moon. So that before closing my presentation, I would like to say that why will human return to the moon? Is it necessary for human to go to the moon and beyond? Yes. From my experience as a researcher in space exploration, I believe so. The reason why, this is 2011, March 11, we had a disaster in Japan. Science tells such a catastrophic disaster occurs one time per 1,000 years. But who was living there had imagined it would occur on the day after peaceful day. So that we should prepare against any natural disaster. Actually, my hometown is Fukushima Prefecture, and fortunately, my hometown is far from the plant, but occurred something. So I want to say that nature is not always kind to humans. So human will go to the moon and beyond to prepare against natural disaster and to know this world from various aspects. The moon is a very good experience field, and to know not only the moon, but also the Earth and our solar system. So going to the moon and beyond. But going to the moon and beyond will face many, many difficulties. Of course, one country cannot achieve it alone, but many nations, many people will need to cooperate. Then we will recognize that, okay, we can realize the world without border. Okay, that's all. Thank you very much. Okay, can I have 5 minutes? If I can have time, I would like to present a movie. May I? Okay, thank you. Now we are planning to explore the laboratory. Okay, I'm sorry. And, oops, sorry. Okay. Unfortunately, JAXA, our government, has not approved our project planning. But now the many scientists and the engineers and teachers of high school, junior high school are combined. And with them, we are now planning to go to the moon and to enter the skylight hole. And some companies present very impressed. So the one company, this is a game company's president, provided us this movie. Oh. Actually, original one is a 3D movies with using 3D glasses, but it's a normal one. And this is not human astronaut. This is robot. Actually, in JAXA, there are many robot scientists, but almost JAXA's robot scientist doesn't agree with such a robot, because such a robot is use many energy, and there are a lot of failure possibilities for them. Actually, we don't know that such a robot will realize. But a robot scientist in Japan asked me, do you want to go to the moon? But some volcanists or geologists want to go. But you know, the human life is very, very heavy. Heavy means very important. So the first, we send such a robot. And the robot scientist said, if you volcanist and geologist move or sampling in some laboratory on the Earth, then a robot will imitate the same motion of the geologist or volcanist on the Earth. Such a technology is now realizing. So they say, let's go to the moon, and we will send such robots. I don't know that this image is the real one, true one, but in near future, I hope this picture, same picture or similar picture will be sent from the moon. I hope. Thank you. Our project name is Uzumen. Thank you very much. That's all.